Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, boats to save people. So basically we have an array of people, where people at index I is the weight of the ith person. And we have an unlimited number of boats, right? And each boat has two conditions. It can carry a maximum weight of limit, and limit is given as a parameter. And it can carry only two people at the same time. So only two passengers at the same time. And the sum of the weights of the 1 to 2 people on it has to be less than or equal to limit, right? And the goal is to return the minimum number of boats that can carry every person, so all the people in the array. So let's take a look at the first example here. So we have 1, 2, and limit is 3. So one obvious solution is just to have 1 and 2 take the same boat. That would be their weight combined is 3, and so that's within the limit, so we return 1 because we need only one boat. This second example and limit of 3, our options are 3. This one, since it's just 3, it has to be in a boat alone, so we do that. And then 2 and 1 can be in the same boat, right? Because 3 is within the limit, so that takes the second boat, and now only 2 is remaining, so it has to take a separate boat, and so we have 2, and so overall that's 3 boats, so return 3. This is the minimum. So that's sort of the idea. Now if you look at the bounds, people array can be big, 10 to the power of 4, and we are guaranteed that each person weight, so a single person's weight, doesn't exceed the limit, so that simplifies the problem a little bit. Okay, so let's see how we can solve it. Okay, so how can we solve this? Well, the first thing you need to think about is, so what does this mean, right? So what we want is to minimize the number of boats, right? And so is there an optimal strategy we can take, right? So let's take a look at this example first, because it's sort of the most interesting one. So if you take a look at this, one thing we can notice is that if you take the smallest weight person, right, and pair it with the heaviest weight person, now if the sum of these is smaller than if the sum of these is bigger than limit, right? What does that mean? Now if the sum of these is bigger than, that means, because this is the smallest one, if you take another person, the weight would be bigger, so this sum would be bigger, right? And so that means this person here, right, has to go on a boat alone, right? Because if you take a look here, that applies actually to 3, so our limit is 3. Because 3 plus 1, which is 1 is the smallest weight, is equal to 4, which is bigger than limit. That means if you take bigger values than 1, than the smallest one, the sum would be bigger, which would be still bigger than limit, right? And so that means this 3 here has to go alone. Okay, so that's already one observation here that can guide us to a solution, which is as long as the heaviest person plus the smallest weight person is bigger than limit, let's just put this alone. So what that means basically is, to be able to easily get the heaviest and the smallest, to do that check, we need to sort the array, right? And so we sort it like this: 1, 2, 2, 3. Okay, and so how do we get the heaviest and the smallest? Well, we can just have 2 pointers, right? Left, and then have another pointer for right. And now we can just check, right? So we can check, is left plus right. So if basically, let's call this the array of people, let's call it P, right? So if the weight of the smallest person right now and the heaviest one is bigger than limit, that means basically, this means that that the person at position R needs to go on a boat alone. right? And so we can just give it a boat, and so we will need to maintain a count of boats, right? So we can just give it a boat, and since we've taken care of it, we need to move our pointer here, right? Because we already taken care of this one. And so to do that, we can just decrement r. So now another way to write this is to handle smaller or equal than limit, so within the bounds. And then in the else case is where it's bigger, and so it has to go on a boat alone. Now what happens if it's within the limit? So like in this case, 1 plus 2, which is equal to 3, so it's equal to limit, so it's within the limits. What should we do in this case? Well, in this case, it's obvious. It's better that both, because the limit is at most 2 people, so we can't take a third one. And anyway, this is, you may say, what if we, why not try 2 and 2? Well, that would be bigger, and so we'll have less chance of it working, right? And so here it just makes sense to take both on the same boat because they are within the limit. So what does that mean? So we increment count again. But if we taking both means let's move our right pointer, right? And also let's move our left pointer. So both are now on the same position. And so here we need to move both. So to move left, we increment by 1, and to move right, we decrement by 1. Okay, so now what should we do if they are equal? So let's first separate both. So this would be the loop when they are not equal. But what should we do if they are equal? Well, if they are equal, that means there is only one element remaining, right? If they weren't equal, it would be bigger, right? So that means we are done. But if they are equal, that means there is one element remaining and we need a boat for that element. And so we can just do one final check here, which is if they are equal, that means we need one boat remaining. And this basically happens, let's say, happens in this case because it's one remaining. But let's say if we had maybe 1, 2, 1, 2, then we won't need it because we will sort it first. We'll get 1, 1, 2, 2, and then we'll pair this 2 with this one, and then we'll pair this one, and we'll be done. They will cross each other. And so not in every case that we will get both are equal. So that's why we do this check here. So if they are equal, we'll increment the count because we need one boat for this last person. And that's pretty much it. We can return count. Okay. And so that's exactly what will happen here. But let's just make this really clear. Let's apply it. So we need count equal to 0. And first our left is here. And then our right is here, right? And so since 3 is bigger than 1, the 3 plus 1 is 4 is bigger than limit, that means we just increment our count by 1 and move our right to the left, right? And so that would be here at 2. And then now 2 plus 1 is within the limit, right? It's smaller or equal to 3. And so we increment count, but we also decrement L. So now L, and then our R, let's just have them here. So this would be the indices 0, 1, 2, 3. Right, so was the index of right? It was 2. The index of L was 0. So we increment the index of right. Sorry, I reversed it. 2 and 0. So increment left and decrement right. Okay. So now they are both at the same position. So we check these are equal, and so we need a boat for this 2, and so increment our boats, and so it's 3, and that's what we return here. Okay. So that's the idea. Now let's just use the same logic that we had and put it in code here. So we just use this 2 pointer, and then we do it like that. Now you notice here we are doing this count plus 1, both here and here, so we can move it outside of the loop like this, r minus 1. The other thing you notice is that we are doing r minus 1 in both cases as well. So let's move that as well. And now we no longer need the if else because those 2 apply in both conditions. So that's just a simplification. And then what we need to return is count. Okay, so now let's run this. Sorry, here, yeah, looks good. We just need to initialize them. So left starts out as 0. and this is length of people, but we also need to sort, right? Because otherwise we can't guarantee that the left one is the smallest weight and the right one is the heaviest weight, right? So we need to sort people array first here, people that sort, and since this is the last position, it's actually the length minus 1. Okay, this is actually people instead of p. P was just a simplification. And if we run this, looks good, let's submit. And this passes our test cases. Yeah, so what's the time complexity? So this here sorting is O of n log n. And this loop goes through the array only once, so it's O of n. And so overall, O of n log n time is the dominant factor, so O of n log n time. In terms of space, we are not using any extra space, just variables, so it's O of 1 space. Yeah, and that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.